Hello everyone and welcome to your lesson of physics. We are going to solve mock paper 1 today. Alright, so there you go. Which pair of quantities are physical quantities? Physical quantity must be having a unit and a numeric value. So for this one, we have D as the right answer. So time period has C unit second and potential difference has the unit voltage. Alright, then we have the next one. We need to find the SI base units of K. K equals to F over RV. Then we insert the base units of these quantity. Force is kgms minus 2. If some of you could remember, we had the similar question in paper 2 also. So radius is meters. Speed is ms minus 1. We are left with kg here. One of the meters is cancelled out. The one at the bottom shifts upstairs, minus 1. And s minus 2 plus 1 would be, because this one would be shifted upstairs, it would be plus 1. So kg m minus 1 s minus 1. Let's move on to the next one. Which estimate is reasonable? 1 into 10 to the power minus 3 for the mass of 1 grain of a sand. So basically 1 grams. They are saying 1 grams is the mass of the grain of sand. 1 gram is too big for a grain of sand. Grain of sand is usually in milligrams. Volume of a tennis ball. Okay, in order to calculate the volume of a tennis ball, you need to estimate the radius of the tennis ball. So in order to estimate the let's say the radius of the diameter of the tennis ball is approximately 6 centimeters. So the radius would be approximately 3 centimeter. If you use the formula 4 over 3 pi r cube, 4 over 3 as it is, pi as it is, the radius would be taken as 0.03 and the cube of it. So the volume that you'll be getting would be way too small, and this volume is way too big for it to be a volume of a tennis ball. The last one is the power of the light bulb in a house. They say the light bulb is approximately 10,000 watts. No, it's not. The light bulb is somewhere around 100 watts, 150 watts. Now we have the ones 20 watts, 30 watts, 50 watts. But at maximum, it is 100 to 100. That's it. So the only option you're left with is the option C. The work done in lifting an apple from a waist height to head height. So the work done would be equal to mgh. So assume the mass of the apple. So let's say mass of the apple is half a kilogram. G is 9.81, or you can estimate, for estimation you can use it as 10. H would be, let's say 1 meters. 5, which they say 1 into 10 to the power 100. So the closest, now you have to make a comparison among all 4 of these. The closest one would be the option C. Okay, let's move on to the next one. We have to calculate the value of n. We'll make Vn the subject. Vn equals to 2f over Cd into density times area. And now everything which is unitless would be raised from the equation. Cd is also a unitless quantity. It's given in the question. It has no unit. Now what is the unit of force? kgms minus 2. Divided by, what is the unit of density? kgm minus 3. What is the unit of area? Meter square. And then what is the unit of speed? On the left side, ms minus 1 raised to the power n equals, let me simplify the right side also. For example, kilogram cancelled out by kilogram. So what are you left with? Meters. At the bottom you have m minus 3 and m2, which would be m minus 1, and you have s minus 2 at the top. Minus 1 shifts upstairs, so you'll be having m2 into s minus 2. So m2 into s minus 2. Now the right side can also be written as, I mean, some of you can already see the answer, but let me write it anyway. You can write the right side as ms minus 1 raised to the power 2. Now the bases are same, so the you can compare the exponents. So thereby n equals to 2. Let's move on to the next one. A micrometer screw gauge is used to measure the diameter. Okay, the diameter readings are given along with the absolute uncertainty. What is the percentage uncertainty in the volume? The shortest way to solve this one is find the percentage uncertainty in diameter. It would be same as the percentage uncertainty in radius. You should know this thing. Percentage uncertainty in diameter equals to the percentage uncertainty in radius. And for the volume, says the formula is 4 over 3 pi r cube. Whenever the percentage uncertainty is, you have to multiply by 3. That's the rule. Whenever we have the exponent, then the percentage uncertainty is multiplied by the exponent. Now, what is the percentage uncertainty in diameter? 0.01 divided by 5 into 100. So it would be 100 divided by 1 divided by 5. So the answer of this one would be 0.2%. So this is a percentage uncertainty in diameter and also in radius. Percentage is same. Now you multiply this by 3. So you get 0.6%. We don't even need calculator for this one. Forces of magnitude 247 combine to produce a resultant force, which is not the possible magnitude of the resultant force, 0 Newton. So let's say I place 2 Newton here and the 4 Newton also here and 7 Newton to the right side. Now what is the lowest value that I can get? I'll be getting 1 Newton to the right side. There is no possible combination by which the magnitude of the resultant force would be 0. Then question number 7. Now for this one, two projectiles X and Y are fired into the air. Okay. Air resistance is negligible. Which statement is correct? So you're shown with two different paths. They reach the same maximum height. The thing that is going to be same for both of them is the time to return to the ground. You know it for the fact. We can prove it mathematically also, but you don't have to. In paper 1, you cannot be wasting that much time. So they'll be taking the same time to return to the ground. Because we said this thing, in projectile motion, the quantity that relates horizontal as well as the vertical motion is time. Time is same for the horizontal motion as well as the vertical motion. A small glider moves, okay, and all that. Let me read them importantly. The glider moves at a constant speed between collisions, and the collisions are perfectly elastic, which means the velocity is not going to be decreased. So which graph represents the velocity? A and B not even considered because the collision is perfectly elastic. At each end of the track, A track, the collision is perfectly elastic, so the kinetic energy, hence the speed, should remain constant. Now we have to compare between C and D. So since it is moving at a constant speed, so it would take a equal interval of time for equal change in velocity for a specific velocity. So that's why C cannot be the option, and the only option we are left with is D. Then we have question number 9. We are provided with the momentum time graph, and they say what is the meaning of the gradient at a particular time. So gradient is of this graph is basically the average force or the resultant force. Or you can say the average resultant force. And then we have the next one. A ball is dropped downwards, it hits the ground, the contact force is P, the contact force N. So P, basically P and N are pair of action and reaction forces. P and N are pair of action and reaction forces. What do we call that? The normal contact force. It is N, and the reaction of that force is P. So this is basically a pair of action and reaction force. So when the ball is in contact with the ground, the ball is momentarily stationary, and then it bounces off. It bounces upward, obviously. At this instant, what relationship is correct? So the resultant force would be the greater force minus the smaller force. The resultant force would be the greater force minus the smaller force. So resultant force equals to this thing. How do we know which one is the greater force? N is greater than W. If, let's say, if W were greater than N, then why would the ball become stationary momentarily? The upward force is greater. That is the only reason that the ball slows down and then it comes to a stop, and then after coming to a rest, it bounces off. So the upward force in this case is greater than the other one, W. So N is greater than W. Alright, then we have question number 11. Okay, so which velocity time graph shows the best motion of the stone when it is released until it hits the sea? Okay, we'll need to read the first thing also. A person stands on the edge of a high cliff and throws the stone vertically upward, so this velocity should decrease. Velocity should decrease. The air resistance acts on the stone. The air resistance also acts on the stone. So the acceleration is not uniform. So A is not considered. And also the stone eventually hits the sea. Now, two things. You would be able to solve within seconds if you try to do it smartly. So the person standing on the cliff, and here we have the sea. He first throws the stone upward. So the velocity in as the stone is thrown upward, the velocity would be in certain direction. It could either be positive, depending on the convention. It could either be positive or negative. And when the stone is coming towards the sea, the direction of the velocity is now changed. So whatever the convention is, if upward was positive or if upward was negative, then now as the stone is coming downward, the direction of the velocity would be changed. Thereby, C and D can be eliminated straight away because they have the same direction of velocity. Velocity is always positive, velocity is always positive. But since the ball goes upward, then it comes downward, which means the direction of the velocity is changed, so it should be B. And I can also tell the convention. Initially, the velocities are negative. So according to their convention, upward velocity they have taken as negative and they have taken downward as positive. So by process of elimination, it would take a few seconds. Okay, then you have the next one. It is a perfectly elastic collision, so relative speed of approach should be equal to the relative speed of separation. So y is moving to the right side, and we don't know the speed of x. So 20 minus 7 equals to x, which is 13 meter per second, and it should be to the left. So x would move to the left with a speed of 13 meter per second, and y would move to the right with the speed which is given as 7 meter per second. Only then the relative speed of separation, which in this case you can see would be 20, and the relative speed of approach was also 20. By any other option, these two speeds would not be equal. Okay, so we need to find the magnitude of the torque and the resultant force. One force is upward, the other same force is downward, resultant force is 0. I'm going to find the torque, which in this case would be the torque produced by the couple of forces, which is equal to the force times the perpendicular distance between the two forces, which is 2 point, sorry, not 2.3, twice of 2.3, which is 4.6. So 0 resultant, and 40 times 4.6 cannot be 92. So C should be the option. Two ways of hanging the same picture. We need to compare the result, the reaction force and the tensions. So you see R1 is equal to R2 because R1 equals to the weight. It has to, the total downward force should equal to the total upward force. The downward force is the weight of the picture, and the weight of the picture should be equal to the force R. So R2 is also equal to weight, which means if A equals to B and B equals to C, it also means A equal to C. So these two forces are equal, R1 and R2, and both of them are equal to weight of the picture. So which means we can eliminate option C and D. And the tensions cannot be same. I mean, if you be smart enough here, you'll see the tensions. You're left with A and B. Okay, you're left with A and B. The tensions at different angle cannot be same. So T1 and T2, you see T1 is at different angle and T2 is at a different angle. These two tensions cannot be same. So the only option you'll be left with is B. But just in case, how do we know T1 is greater than T2? Okay, just for the clarification, but you can see we were able to solve this question within seconds by just being slightly smart enough, and by the process of elimination we can easily answer this one. But let's just find why is T1 greater than T2, which is the option B. So if I write down the expression, let's say this angle is theta 1, and this angle is theta 2. So R1 equals to, so the vertical component of T1 would be T1 sine theta 1. Likewise, the vertical component from the other T1 would also be T1 sine theta 1. So the total upward force is R1 and the total downward force would be T1 sine theta 1. Likewise, for the other diagram, you'll be getting the same equation. The total upward force is R2 and the total downward force would be T2 sine theta 2. Then T1 equals to R1 divided by 2 sine theta 1, and T2 equals to R2 divided by 2 sine theta 2. So r equals to the weight. So everything else is constant. So if I increase the angle theta, then T1 should decrease. They are in denominator. If I increase the angle theta, then T1 would decrease. So which one of these two have greater angle? T1, sorry, T2 has a greater angle with this horizontal line. It has a greater angle. Hence, it would be having less tension. They are inversely related. You see, if I increase theta, then tension would decrease. That's why we know T2 is less than T1 or T1 is greater than T2. But this is just for confirmation. If you be smart enough, you want to save the time, the question should have been solved within seconds. Okay, question number 15, we need to find the average pressure exerted by the object on the table. The volume of the sphere is 4 over 3 pi r cube. This is not a sphere, this is a hemisphere, so the volume would be 2 over 3 pi r cube. Half of this one would be 2 over 3 pi r cube. So pressure equals to force over area. Force equals to weight. Weight equals to mg divided by area as it is. So the area of this thing would be the area of the circle. Okay, so think about it. You have the hemisphere that looks something like this. And the area of contact would be this area, which is the area of the circle. So it is the same thing. Just think about it. You place it in this orientation. So the base of the hemisphere is the circle. So area would be the area of the circle. So area is pi r square. Mass can be written as density times volume g as it is. Now volume would be the volume of the hemisphere, which would be half of 4 over 3. So 2 over 3 pi r cube g as it is, and pi r square as it is. Then you can simplify this thing. I'll shift 3 downstairs. Now pi eliminated, and r square, the powers would be left with r raised to the power 1. So we're left with the option D. 2 over 3 rho r g, which is the option D. Okay, then we have the next one. We need to find the volume of the sphere below the surface of the sea. Alright, the weight of the string and all that is 2 Newton, and the weight of the sphere is 5 Newton. Since it is held stationary in equilibrium, so the total downward force should be equal to the upward force. The upward force is upthrust and the downward force is 7. So 7 equals to, what is the formula of upthrust? Rho density of fluid times g times the volume of the object. So 7 equals to, what is the density of the fluid? 1.03 into 10 to the power 3. The value of g is 9.81, and v would be there as it is. Okay, then the very easy one. What is the center of gravity of an object? The point where the entire weight of the object may be considered to act. So 74% is not the wasted power. That's the only trick here in the question. It's phrased in a way that it appears 74% of the wasted power is 230. No, it's not. the system is 74% efficient, okay, it means it wastes only 26%. So 26% of the power is wasted. That's the trick here. If you read the question just very casually, so it would appear that the wasted power is 74% and the wasted power in watts is 230, but that's not the case here. So it wastes only 26% because it is 74% efficient. So if it wastes 26%, then the wasted power is 230. Let's say if it wastes all 100% of the power, it would be x. Now we can find the total input power. So x equals to 23,000 divided by 26. Hope the screen is fine now. 23,000 divided by 26. It is 884. 884 watts. So the input power is 884 watts, and now we need to find the useful output. So input minus the wasted, which in 2SF would be 650. So the question is tricky in a sense. If you might misinterpret the question. It doesn't waste 74%. This is what I also thought initially, that it wastes 74% and the wasted is 230. No, it wastes only 26%. 74% is the efficiency. Okay, just the last two. Uh, projectile of mass this much, height this much, traveling at a speed. Okay. So we have two situations for the projectile, position A and position B. We need to find the work done against the air resistance during this time. So the total energy at A should be equal to the total energy at B. If they are not equal, the energy at B is less. It means that energy is wasted to overcome the friction. Now what is the energy at A? The energy at A would be the sum of kinetic energy because it's moving, plus the GPE because it's at a specific height also. So what is the speed at A? 15 meter per second. What is the height at A? It is 35. The speed at B is 5 meter per second. What is the height at B? It is 35. The initial height is 30. Initial height is 30. Now the final is 35. The energy at A is the sum of GP, MGH, MGH plus kinetic energy 1/2 m v square, this one. Now energy at B, the total energy at B would be m g h, which is 35, plus the kinetic energy would be 1/2 m, and v square would be square of 5. So you simply insert these two values on the calculator and find the difference in the two energies. If you do it the right way, the calculation, the answer would be 13. Yes, you can find the total energy at A and you can find the total energy at B. And the total energy at B would be slightly smaller than the total energy at A. Technically, if there were no air resistance, the two energies should have been equal, but since these energies are not equal, so the remaining energy was wasted, or the remaining energy was used as a work done against the air resistance. Okay, just the last one. What is the strain of the extended spring? The formula of strain equals to x over L, extension over original length. So we shall first find the extension. Extension equals to force over spring constant. What is the force? How much force is given? 35. What is the spring constant? 420. So 35 divided by 420, 0.083. Okay. Meters. Because the spring constant was given in per meter. So that means the extension in centimeters is 8.3 centimeters. So 8.3 is the extension. The original length is 4.3. Both are in centimeter. The answer would be more than 1, greater than 1 but less than 2. So it should be C. You would have been having exactly 2 if we have 9.0 at the top. But just do it on the calculator. Don't take any risk. So we have C as the right answer for this one, 1.85. So the situation is the force extension graph of an elastic material, of a rubber, looks something like this. So the first one is the force extension graph of rubber. The second one is the force extension graph for steel. And the last one is the force extension graph of a brittle material, for example, a glass. It is no longer included in syllabus, but we'll just go through it anyway. So if we take a look at the given options, then this one should correspond to Y steel, the last one glass, and the first one rubber. But you don't need to worry about this one. And then here we have the next one. We have a progressive wave and the particle P and Q on the surface of the water. P is a fixed point, Q is a fixed point. Which graph represents the phase difference against time? So we need to find the graph for the phase difference against time. If we have a fixed points, then the phase difference between those 2 points should be same or would be same, unless we change the points. I mean, if the first one is P here and the second one we change the point Q from here to here, only then the phase difference would change. Otherwise, the phase difference between these 2 points would remain same. So we'll pick up the option in which the phase difference is constant. Alright, then we have the next one. We are provided with the water wave and which 2 particles are about to move upwards. For a progressive wave which is moving to the right side, the direction of motion, the simplest way is you can draw the direction of motion with respect to the part of the wave that is behind it. For example, P is over here. At the back of P, the wave is something like this, in this direction. For Q, the wave just behind Q is in this direction. At R, the wave behind R is just in this direction. At S, the wave is in this direction. So you need to take a look at the part of the wave behind that one. So this part here, this part over here, this part over here, and this part over here. Now, how many of these are facing upwards? It is Q and it is S. These two are upwards. So Q and S. So this is the easiest way you can predict the direction of motion of the particles on a progressive wave. Otherwise, you'll have to draw the wave for example. I would know that the wave would now move forward as something like this, but it would become difficult for you. So the easiest method is this one. Now let's move on to the next. A loudspeaker emits the source emits a sound with a frequency fs, f sub s, which is the source frequency. The loudspeaker is attached to a car that is moving with increasing speed towards the stationary observer. So if it is moving towards the observer, the observed frequency would be greater than source frequency. So we have to pick between option A and B. And since the object is moving with increasing speed, since the object is moving with increasing speed, so the frequency would also be increasing. The observed frequency would be greater than source frequency and it would keep increasing. Which statement about the electromagnetic waves in a vacuum is correct? Amplitude is proportional to velocity? No. Intensity is proportional to amplitude? No. Intensity is proportional to the square of the amplitude. Velocity is proportional to the wavelength? Nope. Their velocity is constant. The velocity of these waves is 3.0 into 10 to the power 8 meter per second. Frequency is inversely proportional to the wavelength. Yes, it is. Because frequency equals to V over lambda. Since their speed is constant, so we can say their frequency is inversely proportional to wavelength. Okay, then we have the next one. I can see we have two polarizing filters. The first one is at an angle 30. You can always draw an angle on both sides of this vertical line. So the first one, we have the angle 30, and then we have the another polarizer which is at an angle of 90 with respect to the vertical axis. And initially we have a polarized light. The light is polarized already, so we can use a Molus law here and here also. So let me find the intensity after the first polarizer. So intensity after the first polarizer would be I naught cos square theta, which in this case is 30. So cos square of 30. So I naught and cos square of 30 would be, I can find cos 30 first and then I can take square of it. I get 0.75. So 0.75. So the intensity after the first polarizer, after this polarizer is 0.75. But we have another one afterwards. So what is the intensity after this one? Now your original intensity is 0.75 I naught times cos square theta. I'm going to use this formula once again. We're using the same formula. Now what is the angle? The angle has to be with respect to the previous one. So we started off from 30 and we go all the way to 90. So what is the angle in this case? 90 minus 30 is 60. So I equals to, this is the value of I naught. For the second polarizer, this is now the incident intensity. So 0.75 I naught times cos of, what do we have here? Cos square of 60. So times cos of 60. So we get 0.75 times cos 60 square of it. Yeah, 0.1875 I naught, which means 0.119 I naught. Okay, let's move on to the next one. Which statement concerning the stationary waves is correct? All the particles between the two adjacent nodes oscillate in phase. Okay, yes, the very first one. The oscillating phase means they have zero phase difference. So let's say this is a stationary wave and we have these two nodes here. This is node 1, this is node 2. So all the particles between these adjacent nodes have no phase difference. All the particles, they have no phase difference, which means they oscillate in phase, or these particles are in phase. Okay, then we have the next one. Stationary wave is formed. Okay, which pi forms the stationary sound wave with the lowest frequency? So lowest frequency, or in other words, the highest wavelength. The shorter method is, we know that we have the highest wavelength when one, what do we call that? When one end is open and the other one is closed. Then we have the highest wavelength, which means the lowest frequency. So we can discard option A and the option C. Now we have to compare in option B and D. In which one of these two the wavelength would be longer for the lowest frequency? I mean, for the option B, the lowest frequency will look something like this, and for the D, it will look something like this. So which one has the lowest wavelength? The second one. Sorry, which one has the highest wavelength or the lowest frequency? The second one. What is the other method? The standard method. We have memorized the general formula of the first case, which is F equals to NV over 2L. For the second case, if you have memorized the general formula, was 2n minus 1 V over 2 times V over 4L. Third one, once again, the general formula is NV over 2L. The last one, the general formula is once again 2n minus 1 times V over 4L. These are the general formula of these cases. Now let me insert the value of length here. So for example, in the first one, if I insert the value of length and I need the lowest frequency, so n should be 1. N should be 1 because they say what which forms the lowest frequency. So the first harmonic, we are referring to the first harmonic. So for the first one, the frequency would be 2. And what is the length given? 2L. So the overall frequency is V over 4L. Now let's do the same for the second. For the lowest harmonic, N should be 1. So we'll be left with 4 and the length is 2L. So V over 8L. Now for the third one, NV over N is once again 1, because we have to find the lowest frequency, divided by 2, and length in this case is L. Now for the last one, we'll put N equals to 1. So we'll be left with V at the top divided by 4, and the length in this case is L. Now we need to find the lowest frequency. We'll have the lowest frequency for which the denominator is the highest. The first one is V divided by 4L. The second one is V divided by 8L. The third one is V divided by 2L. The last one is V divided by 4L. So which one has the highest denominator? This one has the highest denominator, so this one would be having the least frequency. So this is a standard method of solving this one, but I would always recommend that if you have the basic understanding, you would know already that it is the case when one end is open, the other one is closed. In that case, you get the highest wavelength, or in that case, you get the lowest frequency. Then you can compare between B and D. The one which has a longer wave will be having lower frequency. Okay, so which diagram shows the waves after they pass through the gap? So you need to show the diffracted waves. So A is the option. I mean, this one is the simplest one. Now we have the next one. We need to plot the graph of A against X. A is the slit spacing, X is the fringe spacing. A is the distance between the center of the slits, and X is the fringe spacing. So what is the relation between these two? Inversely. They are inversely proportional. How do we know lambda equals to AX over D? If I make X the subject, I'll be left with lambda equals to X equals to lambda D over A. And if everything else is constant, then X and A are inversely proportional. Whenever two quantities are inversely proportional, the graph is always like this. For example, pressure and volume. The graph of pressure and volume is also like this because those two quantities are also inversely proportional. So mathematically, whenever two quantities are inversely proportional, the graph is always a curve that is sliding downward like this. Which one of which could not be used to create the electric current? Neutrons, because they have no charge. The charged particles can. Potential difference and EMF. Mathematically, they are same thing. Work done per unit charge. EMF also work done per unit charge. But EMF refers to the voltage of the battery. The work done per unit charge in order to move it around a complete circuit. Potential difference is the work done per unit charge to move it around a specific component. Okay, then we need to find the combined resistance of the circuit. So the combined resistance of the circuit needs to be found out. I'll find the parallel of these two and I'll add this one. So 2.2 plus whatever the parallel combination of these two would be. So how do we find product over sum? Product over sum. So 2.2, whatever you get, you write it down here. So you'll be getting C as the answer. the answer of this bracket would be 1 point something, would be exactly 1, matter of fact. And you should know that if you have two resistors in parallel, then the total resistance of those two would be lower than the least resistor, or it would be lower than the least value of the resistance. Okay, then we have the next one. What is the resistance of the resistor? Power is given, potential difference is given. So P equals to V square over R. R equals to V square divided by P. Square of this one would be 16. Power is 25. So you hit it on the calculator, and what we get is B, 0.64 ohms. Okay, then we have the next one. The resistance of the variable resistors is decreased. So this resistance decreases, the overall current in the circuit would increase, and since this resistance is decreased, the voltage across this one would also decrease. So the voltage would decrease, resistance is decreased, so the voltage would also decrease, but the current would increase. So voltage decreases, current increases. Yeah, pretty straightforward. Okay, so what is the average number of alpha particles hitting the metal target? So you need to find the average number of particles. I equals to capital N E over T. Capital N represents the number of the charged particles. Small n represents number density, or uh, number density of the charge carriers. So we need to find N equals to IT divided by E. What is I? Current is 1.5 into 10 to the power minus 9. Time is 3.0 seconds. Sorry. Time would be at, yeah, time is 3.0 seconds. Divided by the value of charge. In this case, it has to be the charge of the alpha particles, not the charge of the electron. Now, what is the charge of the alpha particles? 2 times the charge of the proton, because it has 2 protons. So this value, the charge of the electron or the charge of the proton, is same. The only difference is the sign, but we don't need the sign here. So the charge of the electron would be doubled because the alpha particle has 2 protons. So you can think about it as 2 protons. Charge wise, 2 protons and electrons would have same but opposite charge. So the answer that we get for this one is C. You can hit it on the calculator. Okay, so the charge carrier in the metal wire are free electrons. Which statement about the charge of each free electron is correct? So this is a charge of 1 electron. Which statement about the charge of each free electron is correct? The magnitude of the charge increases with the potential difference. No, the magnitude of the charge of the electron remains same. The overall charge passing through the conductor increases, but the magnitude of charge of each electron remains same. The magnitude of charge is 0 unless there is no. The electron would still have a charge, but the charge passing through the conductor would be 0, but the electron would still have the charge. As you can see in the question, we simply need to mark the flavors of the quarks for which the charge is plus 2 over 3, and that is top, up, and charm. These three have the charge plus over 3. Strange does not have this one, bottom does not have this one. So among the given options, only A is correct. 39. An unstable nuclei emits alpha or a beta particle to become stable. Okay, this nucleus is also unstable and it emits alpha or beta once again. The process continues until an isotope of the original element is formed. What is the minimum possible number of these particles emitted? So very interesting question. So let's say we have an unstable nucleus and the atomic number is, let's say, 10, the atomic mass is 20. Okay, just I'm going to keep it simple. So the first one, it is decayed into something. And this statement is very important. The process continues, this one over here, the process continues until an isotope of the original element is produced. What does that mean? Atomic number should eventually be 10. Isotope means same atomic number. So the atomic number should eventually become 10. So if only alpha particle is emitted, the atomic number cannot become 10 once again, because if the alpha particle keeps emitting, the atomic number would always have a deficit of 2. So if, let's say, this a particle has this element goes alpha decay, so the atomic number would be decreased by 2 and the atomic mass would be decreased by 4. But we don't need to worry about the atomic mass. All we need is that we should be having the same atomic number here. So let's say this one is, once again, this one undergoes another decay, and in this case beta particle is released. So let's say it is now converted into Z. So if we have beta particle released, beta negative, because they said it releases alpha or beta negative particle. If it releases one beta negative, the atomic number would now be 9. So you see, we are going somewhere close to the original atomic number. And if it goes, let's call it Z prime, another decay, beta negative decay, then so this one now undergoes another beta negative decay, or I don't need to extend the equation. I can add 2 beta particles here. So if we have 2 beta particles emitted, then the atomic number here would now be 10. So how many particles have been emitted? 1 alpha here and 2 beta particles here, and eventually the atomic number is same. Now they've become the isotope. So how many minimum particle needs to be emitted? 3. 1 alpha and 2 beta. And I can solve this one in single expression. Let's say this is the alpha. This is a particle. Atomic number 10. Atomic mass 20. This particle is converted into some other stable nucleus. It emits 1 alpha and emits 2 beta negative. So what is the atomic number here? It should be 10. Only then the two sides would have same atomic number. and at the top we should be having 16. But you see, now we have the same atomic number, which means they have now become the isotopes. Say how many particles have been emitted, 1 alpha and 2 beta, so total of 3 particles emitted. So it emits, in the last one, it emits the alpha particle first, so the atomic number would be decreased by 2, so from 85 it would now be 83, and the atomic mass would now be 215. It emits another alpha particle, so atomic number would be 81, atomic mass would be 211. Sorry. From the first one, if alpha particle is released, there would be a deficit of 2 for the atomic number, so it would be 83 here. For the atomic mass should be a deficit of 3, so 213 here. Another time, when the alpha particle is removed or the alpha particle is released, then the atomic number would have a deficit of 2, and the atomic mass would be having a deficit of 4. And lastly, if the beta particle is removed, the atomic number would remain same. So the atomic mass would remain same. So we need to pick up the option which has the atomic mass of 209, and the only option is C.